Problem 1, $500 is put into a bank account earning 2.25% interest compounded weekly for 6 years. Find the balance after the 6 years and the interest earned. Well, we have two different interest formulas. Interest formula 1, A equals P parentheses 1 plus R over N, close parentheses raised to the N T power. And we have interest formula 2, A equals P times E raised to the RT power. And you use interest formula number 2 when the interest is compounded continuously. Any other way that interest is put into the account, you have to use interest formula 1. So this one here says the interest is compounded weekly. So that tells us that we're going to be using this first interest formula. So here our principal, the money invested, is $500. The interest rate R is 2.25%. And remember, when you do these questions, you have to move your decimal point for the interest rate 2 places to the left. So here our interest rate R is going to be 0.0225. Weekly tells you your N value is going to be 52. Remember, N is the number of times per year your account gets interest, and T is the time in years, which in this case is 6. So we're going to plug those values back into interest formula 1 to get our balance. So I'll write out the formula again. A equals P parentheses 1 plus R over N raised to the N times T power. So here, letter P, our principal, 500, parentheses, 1 plus R over N. Well, R, 0.0225, over N, which for weekly is 52, close parentheses, raised to the N times T, 52 times 6, power. Here we have to find the balance, which is what letter A represents, the balance, the money that's in the account after the time has gone by, and then we have to find the interest earned. Well, first, let's enter this expression into our calculator to figure out what the balance is going to be. So here the balance, how much money is in the account after the 6 years, $572. And for money, we always round to 2 decimal places, which means we're going to look at the third decimal place. Since it's less than 5, it's going to stay the same. So here the balance is $572.25. So that's going to be the balance, how much money is in the account. You're next asked to find the interest. And the interest is basically the extra money that's now in the account after the time has gone by. So you started off with $500 in the account. Now you're up to $572.25. So here the interest is going to be $72.25, because the way you calculate your interest, you always take the balance, which is that $572.25, minus the principal, minus the money that was invested, in this case $500. So here the interest, $72.25. Problem 2, $1,200 is put into a bank account in 1986, earning 6.5% interest compounded continuously. How much is in the account in 2014? Well, the first thing you have to do for these interest problem questions is to figure out which of the 2 interest formulas you're using. And here's the key. They tell you the interest is compounded continuously. Since it's compounded continuously, we're going to be using interest formula 2, A equals P times E, raised to the RT power. Here the principal, the money invested, is going to be $1,200. Here the interest rate R is 6.5%. So let's take that 6.5 and convert it into a decimal. move the decimal point 2 places to the left. So here the R value is going to be 0.065. The time that the money is invested for. Well, it told you that the money was put in the bank in 1986. The question is asking you how much is in the account in 2014. So we need to try to figure out how much time has gone by from 1986 to 2014. And the way we're going to do that is we're just simply going to subtract those 2 years. So here the time is 28 years. In this formula, remember there is this number E, which is the exponential growth constant, which is about 2.7, and it's a button on your calculator. It's second, and then the natural log button, second, and then the ln button. So let's enter this expression now into our calculator. We're going to have A equals P times E raised to the RT power. So the balance is equal to the principal, 1,200, times E. Remember, we never substitute in for that. Here the interest rate R is 0.065 times the time, which is 28 years. So we're going to enter this expression directly now into our calculator to get the balance. And remember again, the way we type in this E is we press second and then the natural log, second and then that ln button on your calculator. So here the balance turns out to be $7,406.23. Problem 3, the Greens purchase a condo in 2004 for $235,000. If the condo appreciates about 2.5 a year, what is the value of the condo in 2018? Now this one here, it doesn't seem to be an interest problem because it doesn't say money is being invested, but we're still going to use our interest formula to represent the value of the condo because it's increasing by a certain percentage each year. Here it's increasing by 2.5 a year. And since they're saying 2.5 a year, it's the same as saying 2.5 annually. So we're going to use interest formula 1 because we're not using compounding interest continuously, but rather annually. So that's going to tell us that our n value in our formula is going to be 1. We're going to assume the principal, the money invested, the value of the condo, is $235,000. Here the interest rate R, they tell you, is 2.5%. So when I convert that to a decimal, moving the decimal point 2 places to the left, here our R is 0.025. The time, again, we're going to have to do some subtraction. Here they say the condo was purchased in 2004. They're asking you for the value of the condo in 2018. So to figure out our time, we're just going to subtract those 2 years to get our time of 14. So let's plug into this interest formula 1. Remember, it's annually, so that's why I'm using interest formula 1, and I'm not doing interest formula 2 for continuously. Here the principal, the value of the condo, $235,000. Parentheses 1 plus R over N. Well, R was 0.025. N for annually is going to be 1 raised to the N times T, so that's going to be 1 times 14 power. So to figure out the approximate value of this condo, we're going to enter in this entire side into our calculator. So here the condo is approximately valued at $332,000. $48, and the 7 is going to kick that 4 up to 5, 85 cents. So that's the value of the condo after those 14 years. Here the R, $12,500 is put into an account earning 3.25% interest compounded monthly. Letter A, how much money is in the account after 6 years and 6 months? So here it says it's compounded monthly, so that tells me I'm going to be using interest formula 1. A equals P parentheses 1 plus R over N raised to the N times T power. And for monthly, that tells me that our N value is going to be 12. Here our principal, letter P, is going to be $12,500. The interest rate R, now here it says the rate is 3.25%. Now I know I need to move the decimal place 2 to the left, but here I have 3.25. Now a quarter is the same as 0.25, so really this is the same as 3.25%. So 3.25%, now I'll move the decimal point 2 places to the left, is going to be 0.0325. So the interest rate R is 0.0325. The principal is $12,500. N is 12 because the question says compounded monthly. And now for the time. The time is 6 years and 6 months. So T is 6 years, 6 months. Now, the time always has to be in years. So we can't have it in years and months. So I know it's going to be 6 for the 6 years. But now I have these extra 6 months. Now, I know a full year is 12 months. So really I have 6 of the 12 months. So I have the fraction 6 over 12. Well, 6 over 12 is the same as 1/2. So this is the same as 6.5 years. So I'm going to write that as 6.5. So that's going to be our time. Our time is 6.5. So now let's plug those values back into interest formula 1. And here we're going to have A equals the principal, so that's 12,500, parentheses 1 plus R over N, 1 plus 0.0325 over 12, close parentheses raised to the N times T, in this case 12 times 6.5 power. So this is the expression that you need to enter into your calculator to answer part A. How much is in the account after 6 years and 6 months? So here the balance is $15,435.86. 86 cents. In letter B, if they had to earn interest compounded continuously, so now I'm going to be using interest formula 2 for continuously, how much less or more would they have had in the account? Well, let's plug into interest formula 2. I have the principal, which is still 12,500, so that's letter P, times E, raised to the R times T. Well, the rate is still 0.0325. The time is still 6.5, so times 6.5. So this is the expression that I need to enter into the calculator to get the balance if the interest is compounded continuously. So here it looks like the balance is $15,440.26. So the question said how much more or less. So we're basically comparing these two. They're both 15,000. This one's 435, this one's 440. So it looks like it's more if you compound the interest continuously. And the question said, well, how much more? So in order to figure out how much more, we're going to simply subtract those two values. So it looks like here I get 4.4, which stands for $4.40 more. $4.40 more.